Things get rolling. Okay, so today I want to go over a couple more problems, and then we're going to move on. Obviously, this Thursday you guys have the thing with Scott, so we won't have class, but tomorrow we are going to move on to some slightly new material. I have posted, final test is out there, posted in the folder for week 16. So if you guys want to get started working ahead on that, you're welcome to. I highly recommend it. Pretty much all of next week is going to be dedicated to work time, to working on that final test. I will still go over some things that I think are things that need to be reviewed for you, but that's pretty much what next week is going to be about. The final test is, I mean, you've seen the last few quizzes, the final test is really not horribly pleasant. Not going to lie to you. This time of year is when I stand at the door listening for revving engines before I walk out in the parking lot.
20 pages long.
Well, not quite that bad. Back to that suitcase full money.
Yeah.
So here's the problem I want to look at. We've done a few examples similar to this, but I want to do one more. This is 72 feet across here. Actually, let me draw it a little bit better. Ball, 8-foot bump out, slope, 100-foot ridge, right here, 20. Asking you to find three things here: the volume, the roof area, and the wall area. There's really two distinct problems here that we have to address. First one is the portion of this that has the lean-to on it. That looks that piece looks like this. I'll label the parts that I can label here without causing any issues. Off to the side here, I'm going to draw this sector of the circle here. That sector segment. This height is given as 24 feet. This is 72 feet across here. We know that when I draw out the rest of that circle, that gets split into 36 and 36, half of the 72, right? And I'm going to find X here. How do I find X?
Well, 36, 36.
36 times 36 equals 24 times X, right? Thirty-six times 36 divided by 24 tells us that X equals 54. That means the diameter of our circle is 54 plus 24, 78. Radius is 39 feet. Now back over to this drawing. This height is 24 feet. How much do we have to add on to the bottom of this to make it a full half circle? 15 feet. Very good. So we're going to add 15 feet here. Now, this is the center of our circle. The distance from the center out to here is the new radius of the circle. 39 feet. Distance of the center out to here is still just half of the 72, which was 36, plus the 8, still just 44 feet. Because this came straight down, that distance doesn't change. This went out at the curve, that distance does increase. That becomes the radius. Now let's draw our radius in from the center of the circle out to where that roof hits. Of course, that radius is 39 feet long. Come back to that in a little bit once we have calculated some further information here. I want to connect this corner up here down to the center of my circle. And I'm going to look at that triangle there. This one here, this is 44 feet on bottom. What's this over here?
27.
27, good as the 12 plus the 15. So this length here is the square root of 44 squared plus 27 squared. That is the square root. Good.
Oh, no.
51.62 I'm getting. This is 51.62 feet across here. Next, I want this angle here. This angle is going to be found using the inverse tangent of the opposite side, which is the 27, over the adjacent side, which is the 44. Giving us, well, nodes are not correct.
53.
Sounds right. 31.53. So this is 31.53 degrees. Now this is a right angle down here. That means this angle up here we have found all of the sides of that triangle and all the angles of that triangle. Time to move on to this triangle here. I'm going to look at this corner right here for a minute. Right here. Now I'm going to divide it. We know there's a right angle here. We know this angle is our heel angle for the 312. So that's the inverse tangent. 12, which is what, 14.04 degrees? It's 14.04. That makes this whole angle 4.04 degrees. 1404 plus 90. Which means, if I come back here, this angle is the 104.04 minus 58.47. Makes it 40. 5.51, I believe, degrees. $5.57. Take a closer look at this triangle here. Really, the next thing we're going to find is this angle up here. We know that that is an obtuse angle. You have to know that because it's going to alter the way we calculate it here. $39. 39 feet over the sine, 55.57 degrees, equals 51.62 feet over the sine of that unknown angle. I'm just going to call it alpha. Divide. .9452. After the inverse sign gives me 70.94. Is that our angle?
No,
No, what do we have to do?
subtract by 180.
Subtract from 180. Very good. 109.06 degrees. Which makes this angle here, subtraction, 35.37. While we're at it, let's find this dimension over here. I'll call this dimension D. $39 over the sine, 45.57 degrees, equals that dimension D over the sine of 25.37 degrees. Divide. Nine times the sine of 25.7 divided by the sine of 45.57. 23.40. So I'm going to label that 23.40 feet there. We're going to need that length for our roof area at some point. Okay, so now, not toward that, this angle here. 180, subtract those other two. 180 is 25. That's 31.53. Now I'm going to do something slightly different here from what I have done in the past. I am going to find this angle here and subtract it before we do an area, so that we don't have to subtract that out later. That angle is gonna be found off of this triangle. It'll be the same as this angle here. Remember, this is still 36 feet, half of the 72-foot width. This is the 15 feet we added. So that angle there is the inverse tangent of 15 over 36. $22.62. That's 22.62 degrees. This angle is then 100.48 degrees. And why do I want that angle instead of the full one? Well, now we don't have to subtract this piece off later. We're subtracting it off all right now. And then it's also going to allow me to find this arc length too, which I'm going to need for the roof area. So let's do the parts that we can get off of this piece. Let's find the volume. To find the volume, we need the areas. So I'm going to find 1, 2, 3 areas. And we're going to have to subtract out some areas. But the area of piece 1, 44 feet by 27 feet. $11.88. Area of piece 2, oops, what did I forget there?
5 by 2.
By 2. $5.94. Area of piece 2. You have that A times B times sine of C over 2. 39 times 51.62 times the sine of 25.37 degrees. $94.30. Never mind. There we go. 431.29 looks better. My decimal point didn't get in my angle. And then part 3 is the sector of the circle. So it's pi times the radius of 39 squared times that angle of 100.48 degrees over 360. Per time, 39 squared times 8. 1333.02. $2358.31 square feet is that total area. But now I've got to subtract off only 2 pieces now because remember we already subtract this piece out. So I have this piece here. It is a 44 by 15 rectangle. And I have this triangle over here that is 36 by 15. So I subtract both of those from the 2358.31. $1428.31. That is the area of now. I'm going to use that to find the wall area right now, just to get it over with. 1428.31. Why did I write it down a second time? That covers this wall, but there's one on the other end, right?
Yep.
What else do I still need to add to that? This little piece out here, right? That is 12 by 20. 240. There's a total of 3096.62. Perfect. Of wall area. Now for volume, this gives us a significant portion of our volume. We take the area of this whole end wall times the 20 feet that portion covers. 1428.31 times 20 gives us 28,566.2. Cubic feet, that is part of our volume. For our roof area, there's going to be a contribution. We need to find this arc length here, which is just going to be pi times our diameter, 78, times that 100.48 over 360. Five. $68.36 for that. So I have a total distance here, 68.36 plus the 23.4. That's the whole roof stretch coverage for that portion. 68.36 plus 23.40 is 91.76 feet there, times that thickness of 20 feet. Gives us 1835.2. Perfect. That's a portion of the roof area. So what we have done is we just took a slice out of this. This portion that is the lean-to here, we just took that slice out, we found its volume, we found what it contributes to the roof area. Those are these two numbers we have over here. Now we need to look at the rest of this to get what it contributes to the volume in the roof area. This piece, just this simple one. I'm just going to draw in the sector here because I know this is 36 feet. This distance is going to be 15 feet, and this is 39 feet because I know the radius of my circle already. These, of course, are right angles. Anybody have any questions where this came from? This is all from our previous calculations up before. I can find this angle here. I can really use any trig function. I'll do the inverse tangent to 36 over 15, which gives us, this is what, 67.38, I believe. Of course, the angle we really want is this full angle. $34.76. Over 5 and 6. So now that we have that angle, we can find the area of the sector. Pi times the radius squared times that 134.76 over 360. We got 1787.79. Next, we'll find the area of a triangle. This is 72 by 15 by 2. 540. We subtract. This area here of the segment, 1,247.79 square feet. That means if we come back up here, what does that contribute to the volume? Well, it's this area times 100 minus 20, right? 20 feet was what we took out for this section. 100 minus 20 is 80 feet that this area will span. So we take that times 80, 1247.79, times 80 feet. Gives us 99,823.2. We're going to add to that 99,823.2 the 28,566.2 we already had. 128,398.4. For volume. Finish off some roof area. Scroll back down to this little piece here. Find the rest of the roof area. We need this arc length up here, which is just going to be pi times the diameter of 78 times that angle of 134.76 divided by 360. $91.68 we get. That arc length. That arc of the roof also goes through 80 feet. Times 80 feet gives us 7,334.54. Find our total roof area, we take that 7,334.54, and we're going to add the 1,835.2 we had from the other section. 9169.74. So we got volume, roof area, wall area, everything you could ever possibly want to know and more. Yeah.
If I ever have to calculate one.
The consulting fees for former students are only $40 now.
All right.
Actually, that's true. I do give a discount. Normally, my consulting fees are 80 to, depending on what I'm doing, between 80 and 2. When I do industrial training, engineering training for companies, it's $3,000 a day. That's a 7.5 hour day.
Build a mansion or anything like that, or?
No, I don't.
Right, elevator now.
I've made some stupid mistakes in my life.
Yeah, we all.
One, like getting married. The second was getting divorced. The other option was widowed, which would have been much better.
And then
Shoot,
got
that's on the
remarried.
recording too. I'm shut up. Darn it. You guys didn't hear that.
What are you talking about?
There we go.
Actually, I heard you, but I'll keep quiet if you ask me.
We'll knock it down to 250,000. Give you a discount. How's that?
Perfect.
Yeah.
Yeah, give me a second. Don't confuse me when I'm trying to draw. We go the 612 slope here. We're gonna go 8 foot on the long side for the chimney. First thing I want to find is this here, is this oval that the chimney cuts out of the house. Radius, or the diameter of the chimney is given as 24 inches. So looking at this, I want two dimensions. I want one dimension, B across here. What's dimension B have to become? It is 24. You got it. The other dimension I want is this one here, dimension A. Dimension A is found, can be found one of two ways. The easiest way is to use a slope correction factor. If you recall what that is, we just take our slope, 612, and we make it into a triangle like this. Find the length of this side here, which is just the square root of
12 square.
6 squared plus 12 squared, you got it, is 13.416. And then we divide that by the 12. 1.118. That is our slope correction factor. What that means is dimension A, if we were looking at it straight from above, would still just be the 24 inches for the diameter of the chimney. On the slope, however, it's multiplied by that factor. So it's 24 inches times 1.118. This is 26.83 for A. That slope correction factor is also going to come into play when we try to find the area of that circle to cut out of our roof. Area of the circle, this would be a radius. Now 12 inches is 1 foot, so I'm going to use 1 foot. So that area, pi times 1 squared, otherwise known as 3.14 square feet. That would be the area if you were looking at the chimney straight from above, but it's on the slope. So the area, you can take that chimney times your slope correction factor. 0.14 times 1.118. It actually is 3.51 square feet that it cuts out of the roof of the house. That is the area that the chimney cuts out of the roof. Let's focus on the roof for now. Let's finish finding the dimensions of our roof. 40-foot span, 612 slope. I want to find this height. What's that height going to be? Run here is going to be 20 feet. 612.
40 over x equals.
Careful, be h over 20 because it's half of 40. So yeah, h is 10 feet. That means this length here, the square root of 20 squared plus 10 squared. 22.361 feet. Which means we're almost to the roof area. That roof, 40 feet long, and there's 2 of them, right? So if you take the 22.361 times 40 times 2. That's 1788.88 square feet. That's not our roof area. Why not?
You gotta take out that, yeah.
We gotta subtract that whopping 3.51 square feet. Felt bad if we had forgot that.
No.
That's our roof area. Well, it's not like you don't have a waste factor when you're shingling anyway. So now we got some stuff to talk about with the chimney. This is 24 inches across here, right? Mm-hmm. I'm going to write it as 2 feet across there. 8 feet down the long side, obviously not drawn to scale. I'm drawing this triangle, this is 2 feet. The 612 slope. 6 over 12, I'm going to call this here x for now, equals x over 2. What's x have to be? 6 times 2 is 12, divided by 12 is 1. That's 1 foot, which means this height on the short side is,
7.
got it, 8 minus 1. That height is 7 feet on the short side of the chimney. Everything else goes off of an average height. Our average height here, 8 feet on the long side plus 7 feet on the short side divided by 2, what's that come out to be? 5 feet of average height. I want the volume of that chimney. I take the area of the circle on top here, which is pi times 1 squared, which we already found is 3.14 square feet, times that average height of 7.5 feet. Three 3.55 cubic feet of volume in that chimney. Lateral area of that chimney, if we need to surface it or whatever, is found by taking the perimeter of that base, which is that circle. That's pi times the diameter of 2 feet. That's 6.28 feet is the perimeter of that base. And we take that times that average height again is 7.5 feet. Ends up being 47.10 square feet. I think I've done about all I can do with that problem. What was that?
Just adding it to.
No, this is, can't add them because this is a volume and this is an area. Okay, let's talk about something totally different for a while. Talk about spiral staircase. You guys didn't do the model.
Not yet, we're going
So,
to
you
though.
are gonna do that here?
Yep, we are.
But is that the 16-sided or 14-sided or whatever the heck it is that they,
We don't know, we just talked about how we're gonna do it.
only 2 weeks left, that's gonna be short. You guys know what is the maximum rise you're allowed on a spiral staircase? I believe for spiral you're allowed 9. I'm gonna,
That one we need them.
well, this is saying 8 1/4 inches, but I don't think that. I think you can still go 9. OSHA for industrial standards, I think is like 9.5 actually for equipment, but that's not a.
Equipment and furniture?
What?
Or equipment and furniture?
Well, that's for like catwalks and stuff for an industrial.
Oh,
They get a little bit of a. They're assuming you're a bit more. Remember? Iron up on those. Let's just go with 9 inches. It might be 8 1/4, but we'll keep it simple here and go with 9. So ceiling height of 8 feet, we're at 96 inches. Floor thickness of 16 inches, going to give us 112 inches. Actually, let me make this more. What do I want for a floor thickness? Let's just do 12 inches to make it 108 inches, which means how many risers are we going to have? Divided by 12 would be 12 rises, which means we need 11 steps or 11 treads.
Yes.
If you do a spiral staircase, you have to have a minimum 90-degree landing. Now, that doesn't mean that the steps can't pass underneath that if you have enough height. You only need 76 inches of head clearance. So you can probably have a couple of treads that go underneath there if you really wanted to. Yeah, you could have exactly 2 treads going underneath there if you really wanted to. That's awful tight. 270 degrees here. Let's say that we're going to put one of our steps underneath. So the second step, when you step up on it, you would actually still have barely minimum head clearance. We're going to divide that by 10 steps. 27 degrees per step. That means this would be 27 degrees here. Code for stairway. 12 inches from the center or from the beginning of this tread, you must be at least 9 inches wide here. This is 12 inches. What I'm going to do is this. This is 12 inches. This is going to be half of the 27, so that's 13.5 degrees. What is this side over here going to be? Do we have the 4.5 required to give us the full 9 inches? I'll call that X. Tangent of 13.5 degrees equals X over 12. Find 12, I put that over 1, and we'll cross multiply and divide. That gives us 2.88 inches. Really? Times 2 is 0.76 inches. Is it 9 inches or is it 7 inches I have to have?
I think it's 7.
Is it 7? Okay, that makes more sense. So what I actually have there is 5.76 inches. That's not enough. What we have to do is we cannot start our tread here at a point. We have to start out with some width on that tread, which makes sense because there's going to be a post of some sort in the middle, right? So what we have to do is we have to do this. This is still going to be 27 degrees here. We've got to draw this out here. So this is 7 inches. We've got to figure out what this length here has to be. Call that a length Y since I already used X. This is going to be 3.5, half of the 7, and this is 13.5, half of the 27. We need to figure out what Y has to be. Tangent of 13.5, 3.5 over Y. So I'll make that 1, and I will cross multiply. Divide. So 1 times 3.5 is 3.5 divided by tangent of 13.5. Gives us 14.6 inches, we're going to call that. Which means, this 7 inches can be no more than 12 inches away from here, right? So if that has to be 12 inches or less, that means this in here has to be 14.6 minus 12. It has to be at least 2.6 inches. Which means the diameter of this post in the middle has to be at least 5.2 inches. In other words, 5.25 inches minimum. Which is okay, because they usually, most of these are made out of steel. That's usually a 6-inch pillar in the middle, minimum. Talk about a winder staircase, how that fits in. You guys know what a winder is?
Yeah.
We had that one in the last inches.
We built one in shop.
Don't make any more.
A winder is supposed to save you some steps, is all it is. I am not a huge fan of winders. So you cut this across here, you get an extra step, right? But if you're walking up it side by side or you're carrying something and you have to step over here, there's not much to step on, your foot slips off, it hurts like heck. Or you're coming down it in a hurry and you cut that corner.
Fall down the stairs.
Yes, exactly. Tailbone on the edge of the stair tread is amazing if you haven't tried it.
Some states has outlawed them.
So if we only do a 2-step winder on our platform, that would be a 45-degree angle. Well, if we come out 12 inches there, we'll have to have that 7 inches of width.
The one we built in the shop was 12.
12 inches out, 7 inches of width.
Yep.
That's what I thought. So this has to be 3.5. Now there might be some different rules for winders over the spirals, but it used to be the winders covered the same code as the spiral staircase. Actually, I'm not going to put the 3.5 here. I'm going to put half of my 45, 22.5 degrees here. See what we get. We're going to have more than enough width there. Tangent of 22.5. We'll call that x over 12. Cross multiply and divide. 12 times tangent of 22.5 gives us 4.97. 4.97 times 2 is almost 10 inches. This is 9.94 inches that we would get. Definitely better than our 7 inches that we get. So can we get away with a 3-step winder? Well, let's try. This would be 30 degrees here now, right? So this is going to be half of 30 or 15 degrees. This is still 12 inches, right? It's the right angle. I'll find this dimension. I'll call it A for now. Tangent of 15 degrees equals A over 12. That over 1 and cross multiply and divide. 12 times the tangent of 15 divided by 1 is only 3.22. Double that, we're only getting 6.44 inches across here. We're about 5/8 of an inch, actually not even 5/8, more like 9/16 of an inch short of having our 7 inches of width that we require there. How do we get around it? we notch the winder. You're gonna have to have some sort of a newel post in there anyway, if there's a railing or whatever. You notch it. How far we notch it? Easier if we go off of a round post, by the way. We'll start off with a round post and we'll come out and convert it to square. But if I'm looking at a round post, coming off here again at that 30-degree angle, center of the post, what I'm getting is this triangle here. Oops, the right angle is going to be. This is 15 degrees, 12 inches. I'll call this B. Tangent of 15 degrees. That's not 12 inches anymore. Let me do this. I'm going the opposite way. This is going to be 3.5 inches over here, half of our 7. We're trying to find this dimension here. So the tangent of 15 degrees is 3.5 inches over B. We're trying to figure out what B has to become. We cross, multiply, and divide. 1 times 3.5 is 3.5. And we divide by the tangent of 15. 13.06. 13 and 1/16 of an inch, in other words, which means for this portion to be 12, this portion here has to be at least 1 and 1/16. 0.06 is just under a 16. 0.0625 is a 16. Means if we're going to do this, we have to do the same thing. This post here has to be a minimum of 1 and 1/16 inch. Where? What's the fun? What I want you to work on for me. You still have those 2 quizzes out there. There's a few people that have the first one in. I don't think anybody has the second one in yet, unless they turned it in the last couple hours. You got 2 quizzes out there to work on, and then start that final test. Tomorrow we're going to talk about some other applications, but I will tell you flat out what we're going to talk about tomorrow will not be on.
Perfect.
Then next week, like I said, Thursday we don't have class because of Scott's thing. Next week we will be looking at doing review stuff based on what you need to know to finish that test up. But it'll be all, you can work on the test the whole time if you want to. You don't have to listen to me.